Yeah, both was tag team. Oh yeah. Damn. Damn. I'm slow.
Oh, hi, honey.
All right, guys, let's go ahead and get started. All right. All right. Hey, listen. Okay, our plan for today is we're going to review our 3 topics on vectors. Okay, then on Wednesday, you guys are testing. What's the plan for tomorrow? Do you know?
1:30.
1:30 for juniors and seniors that have already taken and passed algebra, or sorry, English 1 and 2.
Wait, how would
They would have emailed you. And you can also check on Focus.
Okay.
Just look under testing. Okay. Christian, though, you're 10th grade. Isn't that why you're taking it? 9th and 10th have to start. 11th and 12th, though, have to start. All right. Okay, let's try to lock in, please, so that we can get this part of class over with, and then you can work on the review on your own. All right. Okay, number 2. Let's do it. Okay, it gives you an initial point and a terminal point. Okay, remember the initial point is the dot. Okay, the terminal point is where the arrow is pointing. So I want you to graph those 2 spots on your grid. So 1, -3 is here. -7, 9 is here. And then remember, you want to connect. You want to connect starting at the initial and then pointing to the terminal. All right. From there, you are going to count the components of that vector. When I say components, remember I'm referring to the horizontal and the vertical. All right, let's try to lock in, please. We have a lot of side conversations. Okay, we have a test next class. Okay, so you look at your vector and you count the X and the Y. So let's count the boxes. Okay, this is 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, question, is 8, 12 the correct components for that vector? Okay, that is not correct, because why? Negative. On which one? The 8 or the 12? The 8, because I went to the left 8, you got to put a negative there. Okay? For the magnitude, remember, it's 8 squared plus 12 squared. Then take the square root. Okay, on your test next class, you'll be expected to do this 2 ways. The first one is an exact value in radical form. Okay, in that case, you would leave it as a square root. So what I mean by that is you do 8 squared plus 12 squared. And then you'd put root 208. Okay, but the other way you should be able to write your answer is at a rounded to the tenths, which would be actually take the square root of 208. Okay, which is 14.4. Okay. One more thing that I do want to give you is that the symbol for this is the double bars around the V. Okay, so if you don't remember the double bars, that's referring to magnitude, which is just how long the arrow is. Okay, so this arrow is 14.4 boxes. Okay, next one, letter C. We want the reference angle. Remember, you're gonna start with tan theta equals y over x. Remember, no negatives. So that'd be 12 over 8. Then in the calculator, to cancel out the tan, we use second tan. And then 12 over 8. So I got theta equals 56 degrees. Now, remember, that's the reference angle. It's not direction until you consider what quadrant it's in. So you'll see on the board up there, kind of just to the side of the screen, I have the direction chart drawn. Quadrant 1, it stays the same. 180 minus, 180 plus, and 360 minus. Okay, girls. Okay. Then from there, I want you to think about which quadrant -8, 12 would end up in. So if it's -8, 12, I'd have to go to the left, and then I'd have to go up. What quadrant does that put me in? Okay, it's in quadrant 2, and it's that 180 plus or 180 minus? 180 minus. So in your calculator, you do 180 minus 56. Your direction is 124. Okay, but remember, even though you ignore the negatives for the reference angle and the magnitude, okay, when you're doing direction, you have to go back and think about which quadrant the negatives, if they are there, what they put you in. Okay? All right, go ahead and turn the page. So 1 and 2 are very similar to each other. The next one that we're going to work together is number 4. Okay, on number 4, question, how can you tell which of those is a vector? Okay, how can we tell which of those is a vector versus a point? Okay, this one is a vector because it has the pointy brackets. Okay, this one is a point because it's in parentheses. Okay, so we should know the difference there. So it says, given the vector 3, 5, okay, started with the initial point, -4, 2. So go ahead and go to -4, 2 on your graph. And I want you to place a point there. Okay, then it says that you're going to sketch the vector 3, 5. So that'd be 1, 2, 3, 1, 2, 3, 4, 5. Okay, and then it asks you in this case what the terminal point is. Well, that would be where your little arrow part ended up on. So once I did the 3, 5, I'm going to list the terminal point as where my arrow ends. So I can see that this ordered pair would be what? -1, 7 is correct. Okay, then from there, it's asking you the same old 2 questions that we've done over and over again. The magnitude and then the direction. Okay, there aren't that many things we learned to do with vectors. So magnitude, remember your vector is 3, 5. Okay, not -1, 7. This is a point. Okay, we want to use the vector. So if I want the magnitude, it's 3 squared plus 5 squared. Take the square root. Remember, you're going to do it 2 ways. The first one will be an exact value in radical form. So 3 squared plus 5 squared is the square root of 34. And then you'll actually take the square root and round it to the 10th place. Okay, so part of your test is multiple choice that you would need to know the difference. Okay. So besides magnitude, you should be able to find direction. And remember, direction is 2 things. You find the reference angle, then do the chart after that. So second tan on your calculator, is it x over y or y over x? Y over x. So it'd be 5 over 3. And then in your calculator, do second tan on that. Oops, I did it twice. Okay, I got 59 degrees. Okay, now I need to consider what quadrant I'm in. Now look at my vector carefully. Okay, right now, what quadrant is my vector in? Quadrant 2, but remember, before you pick what quadrant it's in, on your homework, do you remember you'd click it and drag it back to the center? So if I could click this vector and slide it back to start at the center, which quadrant would it be in? 1. Then this is a quadrant 1 vector. So you can't click and slide it because it's on paper. Okay, but this is in quadrant 1. Another way that you could know that is look at the x and y of the vector. If they're both positive, you go to the right and up. What is the formula in quadrant 1? It stays the same. So your direction would still be 59. Okay. So remember, your first thing that you find is the reference angle. And then after you choose your quadrant and which formula to use, then it goes to direction. Questions on that? Okay, very good. All right, go ahead and take a look at number 5. Okay, you have a vector u listed, and then they ask you for 2 times vector u. What does that mean you need to do? Okay, times by 2. So 2 times u is going to be double the -5, 4. Okay, also remember that when you're multiplying a vector, you got to do the x and the y together. So 2 times -5 is -10, and 2 times 4 is 8. Okay, then from there, it's going to ask you to do magnitude. Do you know how to do it? Reference. And then direction. Can y'all do it on your own? All right, turn the page. Okay, if you need help, I'll give you the formulas real quick. Okay, if you want to make these notes, you can. All right, next example that we're going to do together, okay, is going to be number 7. Okay, number 7 is an algebra, basically, where you're doing stuff with the vectors. Okay, remember, you can only multiply vectors by numbers. You can only add vectors with other vectors. So on the next page, let's say that I'm doing letter C. So I want P minus 2 times U. Then I'm going to do P minus 2 times U. Okay, girls. And then in those spots, I'm going to put vector P in the first blank, vector U in the second blank. So it tells me that P is a 2, -7. And then it tells me that U is 5, -. Okay, what operation should I do first? Multiplication or subtraction? What am I multiplying? Not just the 2. Very good. Okay, the -2 has to times into both of these digits. Now, for the first vector, if it doesn't have anything in front, do I change it at all? No. So my 2, -7 is going to stay the same. But my 5, once I times it by a -2, is going to be a what? Yes. And then what about the -2 times the 4 that's already negative? +8. Okay, then one more thing that's important. Remember, the minus from the middle, you pushed it into the vector. So now this is a plus in the middle. And then when you add vectors, you put the 2 x's together, put the 2 y's together. So if I do 2 plus -10, my new x is a -8. And then -7 plus 8, my y is a 1. Okay, the little blanks at the top where it asks you to rewrite the vectors in terms of I and J. So if I wanted to rewrite, this is P right here, it kind of got hole punched. Okay, but if P is 2, -7, do you remember you just put 2I minus 7J? You remember that from the homework? You're literally just putting I with the first number, J with the second number. Now, if the 7 was positive, you make it a plus. Okay, what would vector U be if it's 5, -4? 5I minus 4J. So that part should be pretty straightforward. Okay, next thing, take a look at F and G. If I have a vector P, okay, this is graphically, just think about what's going to happen to the arrow. If I change my P to a half P, what's going to happen to the arrow? So let's say this is my original P. What happens when I cut it in half? It's shorter, very good. Okay, so from P to half P, the arrow is going to be cut in half. Let's do half as long, but points the same way. So when you multiply a vector, you should remember from the delta math, remember how we like stretch it longer or stretch it shorter? Okay, a multiplier changes the length of your vector. Now, what if I take my P and I multiply it by a -3? How much longer is it going to be? 3 times longer, but the negative is going to make it point the other way. So this would be 3 times as long, but it's going to point the opposite direction. All right. Last little bit of this. We're almost done. Okay, number 10. This is very, very easy, and I want to make sure you understand what the instructions are. So it says to resolve A into horizontal and vertical components. That's this formula that we did last class, where you do the length times cosine theta, and then the length times sine theta. Okay, but remember, in order for you to write the vector yourself, you have to know how long the vector is and which way it's pointing. So if they don't give you that information, you can't write your own vector. Okay, but in this case on number 10, they did. For vector A, how long did they tell me it is? You should recognize that symbol's length, right? So how long is it? 9. So it's going to be 9 cosine theta. 9 sine theta. And then what direction did they tell me it's pointed? Says it right there. 105. Very good. Okay, now look, that's the exact value. What do they want you to do when you're rounding to the 10th place? Put both of those into the calculator. See what those numbers are. So type in -9 cosine 105. That's your X. So 9 cosine 105, that gives me -2.3. And then 9 sine 105, that gives me 8.7. All right. Good on that? All right, last question we're doing together. Turn the page. Okay, the last thing that you have to remember how to do for your test, okay, is a word problem. There's going to be one, and it's going to be the exact same format as what's on the back of your sheet. Okay, so we're going to go ahead and do the top one, and then y'all can do the bottom one. All right, so it says we have a jet traveling north 60 east at 250 miles per hour. I want you to write jet equals. And then we're going to write our own vector to represent the scenario for the jet. So how fast is the jet going? So it's going to be 250 cosine something, 250 sine something. Remember, cosine's always in the X, sine's always in the Y. Okay, then from there, you're going to have to analyze the direction that the jet is going. It says it's north 60 east. So let's draw ourselves a little compass here. Okay, this is never eat soggy waffles. Where do I start at 0 degrees? East. Remember, this is the starting point. Just like on the unit circle. And then remember, I rotate this way. So what would that make north? 90. What would that make west? South? Okay, so if I want to go, read it again, north 60 east, north is 90, and then I'm going to tilt 60 degrees this way. Do I add it or subtract it from the 90? 90 minus 60 is 30. And you've done your jet. Okay, next thing that you want is the wind. Okay, it says the wind is blowing south 18 west at 20 miles per hour. So wind equals 20 cosine something, 20 sine something. But then in order for me to know what I put into those spots, I got to think about, you're going to start pointed south, and then you're going to tilt 18 west. So if south is 270 and I'm tilting to the west, do I add it or subtract it if I have to measure this way? Subtract it. So 270, take away 18 degrees. That gives me a 252. Okay. All right, then from there, I want to find the resultant vector. What does that tell me I need to do? Remember, you add the x's together, and then you're going to add the y's together. Okay, girls, please. We're almost done. So you're going to do 250 cosine 30 plus 20 cosine 252. So my x needs to be a 210.3. Okay, then you're going to do the exact same thing with your y's. So take this guy, and then add them up. Okay, remember, you can just kind of copy paste and switch the cosines to sines if you want. Okay, so my y is 105.9. What's that going to round to? 106. Okay, from here, it asks me for magnitude. What do I do for magnitude? So it'd be 210.3 squared plus 106 squared. Then once you get that number, you'll take the square root. 210.3 squared plus 106 squared. And take the square root. Should have gotten 55,462. Then when you square root it, you get 235. Now, quick question. It tells me in the original problem, how fast is the jet trying to go? 250, but it ends up only going 235 because the plane's going north, but the wind's blowing south, right? So it's taking some speed off the plane. Okay, next part E asks for the reference angle. Second tan, y over x is 106 over 210.3. Second tan, 106 over 210.3. We got 26.7. We're going to round that off to 27 degrees. Okay, that's the reference angle. How do I turn it into direction? Consider, yeah, what quadrant it's going to end up in. So look at your X and your Y. What type of numbers are they? Both positive. Then I'm going to go to the right and up. What quadrant am I going to end up in? Quadrant 1. Because I'd go to the right and up is quad 1. And remember, in quadrant 1, you're going to keep it the same. So 27 is your final answer. Make sense? All right, your test on this is next class. Enjoy sleeping in tomorrow. Everybody, I think except Christian, sadly. Our little 10th grade prince that has to get up early. Huh? Inquiry, yeah? I don't mind if you wait till Friday, but Friday's no. Okay. But if you want next class to kind of catch up, go through some detailed math, that's fine. Okay. Okay? Yes, yeah. Do you know how to request it?
I wasn't here when you.
Okay, go into ClassLink. I just figured out how to do it. Yeah, I can't send you a paper.